On the previous episode, we built the RWC stand. Today, we're going to be laying out and installing the piping. You can get these blueprints I designed for this system completely free from the link below. It'll take you to my website, and there'll be a link where you can download that PDF file. This clickable PDF file will provide you a complete bill of materials and the drawings I designed on AutoCAD for this entire system. To build, I transferred the blueprints on my iPad so I can reference them while I was building. Sheet 3 of the blueprints is the bucket and hole layout drawing. First, I mark each measurement from the drawing on both the long side and the short side of the RDWC stand. I then snap some chalk lines. Once I've snapped all the layout lines, I drill the holes for the piping and the air lines. The exact dimensions of these holes are in that clickable PDF. To drill these holes for the 1/2-inch PVC pipe, I drilled a 3/8 inch starting hole and used a 1-inch hole saw. For my reservoir, I found a 55-gallon food drum. To cut the hole for the return line, I just used my iPad as a template, drew a rectangle, and then cut it out. I drilled a 3/8 inch hole and used the jigsaw to actually make this happen. Next, I drilled a 1-inch hole for the RDWC supply line. I lined up the 1/2-inch PVC pipe with the hole that I just drilled into the reservoir and drill a 1-inch hole through the actual stand to run the pipe. I installed a 90-degree elbow towards the reservoir and supply line, and then I connect those two pipes. Now I install the pump in the bottom of the reservoir and measure from the pump discharge up to the 90-degree elbow. I cut a piece of 1/2-inch PVC pipe and install it from the pump to the 90-degree elbow. Next, we measure out for the supply hole to the first bucket and cut using a handsaw. Installed a 1/2-inch T and then cut a small piece of PVC and connected to this T, going up through the table and into our 1/2-inch ball valve. Next, we measure up from the top of the ball valve to the top of the bucket and assemble the supply pipe based on our measurements. Sheet 6 of the drawings has these exact measurements I used. I basically just repeated this and worked myself around the entire table till all the supply pipes were completed. On the farthest hole from the reservoir, instead of a T, I used a 90-degree elbow. Sheet 5 shows this entire pipe layout. For the reservoir return pipe, I used a 3-inch pipe. This will need to be elevated on the opposite side of the reservoir to allow flow back to the reservoir. To do this, I cut a 4-inch hole out of a piece of scrap wood I had laying around. I used a drill press to drill this hole. Then I measured the circle halfway up and used a jigsaw and cut this half-moon pipe bracket. Now on to the drain pipe coming out of the actual bucket itself. I measured up each bucket from the bottom and marked a spot at 10.5 inches. Using a 3/8 inch drill bit, I drilled a pilot hole and then a hole saw in the reverse direction. You do this not to damage the bucket, but warning, I'm telling you, don't put too much pressure on that drill bit, because I in fact did break a bucket. Now I clean up that hole that I just made using a razor blade and install the unisil. Install your drain pipe by pushing it through the unisil, exposing about 3/4 of an inch on the pipe on the inside of the bucket. I place the bucket in its final location and trim down the 1-inch pipe using a T as a reference, ensuring the bottom of the T is pointed down towards the reservoir. I drill a 2-inch hole in the 3-inch reservoir return pipe, again using the drill in the reverse direction. I run a pipe down into the reservoir return. Now please note, I didn't glue any of these pieces together, and you're going to see another video why when I actually do a water change. Inside the bucket, I install a T in that exposed piece of pipe that we put through the uniseal. I use the middle part of the T, and I actually face that towards the bucket. I connect a 1-inch drain pipe from the bottom T to the bottom of the bucket, leaving about a 1/2 inch to the bottom. What this does, we'll do two things. We'll ensure that all flow comes from the top, comes through the bottom, and out the side, and it'll also control the actual level. For the water supply lines, when you go back to sheet 6 and it shows you the layout of the actual stub tubes, I drilled a hole in the 3-inch neck cups and just routed one side inside the bucket and the other side to the actual nipple itself, and that provides you flow through the top of the bucket. And that's really it. It's pretty simple. In the next episode, I'm going to be filling the system and planting the peppers.